Welcome back to 4.2. We're going to look at exponents in scientific notation. We're going to use the power rule to raise powers to powers. We're going to raise a product to a power and a quotient to a power. We're going to convert between scientific notation and decimal notation. We're going to multiply and divide using scientific notation. And we're going to solve applied problems, again, word problems, using scientific notation. Anytime you have an exponent being raised by raised to another exponent, or it's to raise a power to a power, all we're simply going to do is to multiply the exponent. So for example, if we raise these, a becomes x, sorry about that, a becomes x to the 12th, and then 4 becomes 4 raised to the 16th power, and that becomes, we're just going to leave it there, and then C, we get A raised to the positive 6th power, and we're done. Right? Again, when you're raising a product to a power, you're going to distribute that integer all the way through. Everything gets raised. Okay, when you look at this, let's look at A. That's saying 3 raised to the 4th, and then x raised to the 4th. So that gives us 81 x to the 4th. Let's look at B. You have negative 2 squared times x to the 3rd squared. So it gives us 4, and then 3 times 2 is 6, so we get 4x raised to the 6th. On C, we have to look at a little bit different. So you have a squared raised to the 7th, b to the 3rd raised to the 7th. All of this times a raised to the 4th, b to the 5th. So a to the 4th gives us, a to the 2nd raised to the 7th gives us a to the 14th, and then b raised to the 3rd, which is then raised to the 7th, gives us b to the 21st. Then you get times a to the 4th times b to the 5th. That's not our final answer because we can put those together. Now that they have like bases and they're all being multiplied through here together, you can add those. So you have a raised to the 14th and a raised to the 4th. That gives you a raised to the 18th. And then you have b to the 21st and b to the 5th. That gives you b to the 26th. And we're done. Okay, let's look at a couple more. Let's say we have 3x to the 4th, y to the negative 5th, raised to the 4th power, and we have negative 2x to the negative 3, y to the 5th, raised to the negative 3. We're going to work it on all of those. So when you first look at the very first problem, this one here, I'm going to work in blue, you have 3 raised to the 4th, x becomes x to the 16th, and y becomes negative 20. So when we go look at this, 3 to the 4th is 81, x to the 6th stays the same, but you cannot have y to the 20th in the top. Y to the negative 20th in the top, so it becomes y to the 20th in the bottom. So now we have negative 2 raised to the negative 3rd power, and then we have x that is already raised to the negative 3rd power. We're going to raise it again to the negative 3rd power, and then we have y is raised to the 5th raised to the negative 3rd power. So to make So now we're going to work on this one. So you can't have that -3 in the top. So we're going to bring it to the bottom. Now when you multiply the -3 times the -3, that's going to give you x to the 9th. So that can stay in the top. And then you have y, and that's going to give you a -15. So it's going to go ahead and go to the bottom. You can do it in 2 steps or you can do it in 1. It's up to you. So I usually wind up with this right here. This gives us -8. And you have x to the 9th and then y to the 15th. And that 1 doesn't have to stay there. So I'm just going to erase it so that you can see what our final answer is. So our final answer is x to the 9th over -8 times y to the 15th. Okay, raising a quotient to a power. All you do is you distribute that power through the numerator and through the denominator. And if it's negative, if you look down here, if it's negative, then all you do is you just flip the inside and it makes that exponent positive. So, for example, we're going to have w raised to the 3rd over 4 raised to the 3rd, which simplifies w raised to the 3rd over 64. We're going to have 3 raised to the 4th. Now remember, you have to multiply, so you get b raised to the 20th, and this simplifies to 81 over b raised to the 20th. Now on C, you have the negative exponent on the outside. All you're going to do is flip it. It doesn't change the values of the exponents on the inside. It doesn't make them positive. It doesn't change to make the positive ones negative. Okay. Now we're just going to follow the same rules. It's squared. And so b times 4, b raised to the 4th times 2 is going to give us b to the 8th. And a raised to the 5th times 2 is going to give us a to the 10th. Alright, scientific notation is where this gets a little confusing. So let's think about the rules. Scientific notation for a number is an expression of capital M times n raised to some integer. Here's the trick. Where n is an integer, m is greater than or equal to 1. So the number that is hanging out, this big number right here, is greater than, m is greater than or equal to 1. Okay? And then the integer n, we're going to talk about that one too. So positive exponents in scientific notation indicates a large number greater than or equal to 10, and a negative exponent indicates a small number between 0 and 1. So these are your indicators. So let's look at this one. It says to convert to scientific notation. Remember, you want a number that is between 1 and 10. Between 1 and 10, because this is kind of a large number. So you're going to move the decimal place 1, 2, 3, 4. You're going to move it to where you just have one number to the left of the decimal, and you can have as many numbers to the right, but if they're zeros, you just drop them, and it's going to be times 10 to the 4th. Now look at this number. This is a small number, isn't it? So is it between 0 and 1? So it's going to be a small number. So it leads me to believe that my exponent needs to be negative. And again, you just move the exponent to where you have one number to the left, and then you can have as many numbers as you need to the right, but if they are zeros, you can drop them. So that becomes 4.23 times 10 to the negative second. So we moved it 2 places. Now we're going to convert to decimal notation. Now, remember, if you have a positive number, it should turn into a very large number, right? So that means we're going to go to the right, 2, 3. So if we had 3.842, 1, 2, 3, 4, 5, 6, that means we got to put in goose eggs there. A decimal is now here. So now we have 3,000. 3,842,000 is our final answer. Now we have a negative exponent, so that means it's a small number. So we're going to go to the left 7 places. I'm going to go 1, 2, 3, 4, 5, 6, 7. And you're going to drop in your zeros here. So that gives us this number right here. Oops, I left off a 0. 1, 2, 3, 4, 5, 6, 7. Yep, that's it. So that's our final answer there. Alright, anytime you have multiplication in scientific notation, you just take those numbers, the m's, and you're going to multiply them. And then this is the same thing as times. This is saying 10 raised to the 8th times 10 to the negative 5th. So when you have the 1.74, 1.7 times 2.22, that gives you 3.74. And remember, if they have like bases, you just add the exponents. So 10 plus a negative 5 is going to be 10 to the 3rd power. And because this is only one place, that's still your final answer. Now let's look at this one. We're going to do the same thing, except this is division. So when it's division, you're going to do the dividing just like you've been doing. So it's going to be 6.2 divided by 8.0 times 10 raised to the 9th power over 10. Sorry about getting the pens to write today. Over the 8th power. So when you divide 6.2 by 8, you get 0.775. And remember, you take the smallest to the largest and subtract. If you do that, that's going to give us 1 over 10 to the 17th. But when you're dealing with exponential notation, then you want, or scientific notation, it's okay to have that negative exponent, so this is what you really want to have, to the negative 17th. Now, what do you notice right here? It doesn't have one place to the left, does it? So when you move that decimal place one more place, that's going to change our answer. And because we moved it, it's going to be negative 18 now. Because we just moved it 1. And that's your final answer. Okay, an applied problem. A gigabyte is a measure of a computer storage capacity. 1 gigabyte holds 1 billion bytes of information. If a firm's computer network contains 3,500 gigabytes of memory, how many bytes are in the network? So think about it. 1.0 times 10 raised to the 9th, that equals 1 billion, times 3.5, change it to scientific notation, times 10 to the 3rd. Because basically what we're doing is we're doing 1 billion times 3,500, and your calculators can't do that. So you have to create it a little bit different. So 1 times 3.5 is 3.5, and then remember the like basis, so we're going to add the exponent, so you get 10 raised to the 12th power, and that's your final answer. Alright, good luck. I hope you're doing well in this chapter.